Okay. First of all, next week you're going to have a quiz a few days before, a couple of days, the day before, 3 days before, I don't know exactly when, whenever I design the question, you're going to get the ballpark of what the question is. So I'm going to tell you they're going to have a question doing this and this and this. And then that's going to be your question. You are not going to receive any type of, you're not going to receive any type of, you're not going to have any type of help with you. It's only you and the lab computer. So at the time of the thing, it's better to have all your cell phones, smartwatches, and everything in your backpacks, and you put it, right, pack it out over here, okay? You're not allowed to have anything with you. When you come to class, make sure immediately you log into your computers, make sure your computer is working. You actually can log into the Seneca site and make sure everything is fine and dandy. I was wondering to change the way to do the quiz depending on, I'm going to try something because this copy and pasting it seems a little painful. I was thinking to ask you to, if the website, if Blackboard actually shows me the content of your CPP file, I can check it so you can attach a file to your test and literally submit your CPP file to me. Like that, you don't have to do copy and paste. It's going to be quicker, but that only is possible if it shows it to me. So I'll do a test. If that's the case, then I'll leave the option to you. So I'll leave them both on. So you can either copy and paste, or you can simply at the end just attach your answer to the test. And if everything goes okay, then I'm going to create another video and show how to do the things, so no more answering in the thing. So that copy and pasting, it seems a little painful. We'll take care of that. So, where is A? A is here. What we're going to do, as usual, we're going to quickly go through what we have done last time. We're going to do a quick review on what we talked about. And after that, we're going to start talking about topic of today. And hopefully, if I can make it, today we're going to finish all the concept. And the next day you are coming in, we're going to show you, I'm going to show you code examples of the concept we taught. Of course, I'm going to show you little code snippets while I'm going through, but to show you a real thing that is done, it's going to be the next day. So hopefully the next day you are coming in, we're going to be almost up to date with the weekly schedule. Almost. It all depends on today, okay, how it's going to go through. It's a little dark in here. I want to turn on the lights. Anybody have a problem with that? No, I mean, like, if you have a problem, close your eyes. I'm going to do that. Oh, you don't know. Once I did that and somebody went through so it happened to me once during my thing, and since then I'm asking. Some people are sensitive to light going up and down. They go to seizure, so I need to know. So I'm turning the lights on. Wow, this is the dimmest light. Yeah. I think that was the reason they turned it off. Does it make any difference? Okay. Is it better? If I turn it off, you're gonna fall asleep. Okay, so all right, so let's begin. This was last day, so 15th, that we talked about. We talked about, now I'm distracted with something else I have to mention. So when you're coming to the lab, first, I hate to do that. If it's a test, if it's a quiz, sit on these. But if it's a lecture, because you don't see down, so it's kind of covering the screen. So maybe sitting over there and there is better. I'm just letting you know. It's a good idea to see the screen because, yeah. Anyway, so we talked about the real syntax of main and understanding what it does. We said if you want to pass values through the command line to your program, you can actually use the two arguments that we have in main. The first one shows how many C strings are coming in, and the second one is the array of C strings that is coming in. So essentially, by going through argv from 0 up to argc, you can access every single argument that is coming in as a C string. They are all C strings, so if you are reading a number, it's your responsibility to convert that to a number if you want to. Then we talked about the EMV, the third one that is not mentioned in the notes, but it's going to be in a test and a quiz. So that the EMV, that is the third one, shows gives you all the environment variables that you have in a system. There is, somebody brought it up the other day, that we can use getEnv function to get the environment variable thingy, but that's in a header file with I think it's in stdl standard library or something. It does the same thing, which you can actually receive a specific value of an environment variable, but it doesn't give you the list of all of them. You can just check one of them. Anyway, so all the list is coming in there, and the list that comes in the EMV, the list that comes in is as OS variable equals to OS value. Okay, so you are responsible to split it in two. Okay. If you want to know how the getEnv function works, you can actually write the getEnv function yourself. It's actually a very good practice for this. I explained it that you can actually write a function that gives you the environment variable using this thing that is coming in from here. Anyways, so that's that. Then we talked about alignment, and we said each variable has a size in memory. You can use the size of operator to extract that size out. And we said compound types are the sum of the are the sum of the fundamental values, fundamental variables that they have inside, and more, depending on what is the alignment. We said that we said each fundamental type must sit at the address that is divisible by its size. Because of that fact, if we create rec2 over there, for example, we'll see that although I have an integer and a character and a double, and the size over there is 13, but it's actually 16 characters because it has to fill it to make sure that double always sits at address that is divisible by 8. But not always things are aligning to their sizes. Sometimes a compound type is in a way that any way you put it in the memory, it aligns, for example, by 8, which means it can, like rec1, although the size is 16, if it sits at the address that is divisible by 8, both doubles are sitting at a right address, therefore it's good. It can actually be used that way. That's why the alignment of rec1 is 8. So align of tells you what is the alignment of something, size of tells you what is the size. And if you specifically want to change the alignment of something, you can manually set it to whatever you like. Why? I don't have a good example for it, but you can, you may face it in future. We talked about general pointers, which are essentially pure addresses. Those are void pointers. They are pure addresses, and because they're pure address, they don't know what the target is. Therefore, the target of, which is an asterisk, target of dereferencing it is impossible. You cannot do that. You can set a void pointer to any address, but if you want to put the void pointer to a specific type of address, you must cast it. This is useful when you have a general purpose type of a function that you want to pass anything in it. Soon we're going to see in file access that, anyways, but when the time comes, I'll explain it to you. But anyways, this hex dump wants to get a void pointer. Why? Because I want to show the size of anything that is passed through. Therefore, actually, it's not a good idea to put 4 over here. It's better to put size of int. to make this portable, because you don't know what is size of an integer somewhere, right? And size of double. Depending on what the platform is, the size of variables change. So this shows the hex dump of those variables using void pointer. So I don't need to cast address of I and address of x because it's going to the void pointer. But when I want to show that void pointer as packs of bytes, then I have to actually cast it to an unsigned character. So I can actually show it that way. So that's that. We talked about references. We said references are all values, left values. You can put it at left side of an assignment operator. And we said R values are the ones that we are putting at right side of an assignment operator. We said every single L value can be a R value, but not all R values can be left L values. Or the example for it is line number 9. Ref is sitting at left, but 10 must always be an R value. You can never have 10 is set to something because it's an R value and you cannot deal with it. An R value, however, is something can be detected using a reference of an R value. Reference of an R value. So an R value reference can detect the thing that is coming in is an R value or not. In following example, as you see, the first one, because it's a reference, the regular reference will be called, but second and third, because the second one is an absolute R value, it's 20, it will be called with the print that is at line 6, and the second one is a temporary integer that is about to die. That is considered an R value too. So that's going to be passed with the R value reference. If you want to, you can enforce an L value to be passed as an R value. What is this thing good for? The good thing is that sometimes objects have resources that are not used after they serve their purpose. If you want to pass them to a function, copying it doesn't make sense. You can move them, you can actually empty their values if you want to. And that's what we can do. So that move thingy forces an R value to be passed as an L value in case you want to do something about it. We'll see that soon. We talked about range-based loops, and we said range-based loops, essentially, they create, the loop is created using an instance of an element created and a column and then the collection afterwards. The reason I call it collection is that it has to be a collection for the range-based loop to work, which means it needs to know the entire collection to be able to do a range-based. Essentially, the range must be available for the range-based loop to work. The first thing that is an element is called an iterator, or iterator. I don't know how you want to pronounce it. So that iterator's job is to be set to the value of every single element, in that case, for every single loop that is doing. So every iteration, that element will be set to 1. In this case, because element is just an object, every single element will be copied. If you do not want that to be copied, then you have to, well, oh yeah, there you go. So, yeah, then you have to pass a reference, which is here. So now you see the iterator over here that is E, that A is being passed, is going through A, can actually change the values of A because the iterator is a reference, okay? Array initialization happens with the aggregate initialization, universal type of initialization. If the size is not there, it's going to take the size of initialization. If the number of initialization is less than the array, The rest will be nullified or defaulted. And if you don't put anything, everything will be defaulted. But the thing that you need to know, if you put more than the values that you have, compilers may give you a warning. May. So careful. It's not a guarantee. So if I put 6 things over there, if your compiler is smart enough, it's going to give you, hey, what are you doing? You have 5 and you're trying to initialize it by 6. So that is that. We said classes pack the data and behavior together, and that was a quick example for it. Then we talked about how classes get initialized. We said initialization happens 2 steps. New C++, you can initialize every single attribute within the class declaration, which means you don't need to have a default constructor. It all will be defaulted automatically. Okay? But if in the member list area, initialization area, that is the name of the constructor and the body of the constructor, if you start initializing them over there, then it's going to override what you have in the default initializer. So line 8 is not going to happen if the object created using line 11, because name is being set to something. And number 12, for a constructor at line 12, none of them will be set. They're going to actually be set to the values that are passed. We mentioned to be careful because the 2 values should follow the same order of the arguments of the class items that you have. So ID is first, ID should get initialized first. Name is next, it should be next. If you do it the other way, some compilers give you warning. If you try to initialize something inside the constructor body, it's not initialization for the attributes, but it is initialization for class itself. So it means you are initializing the class in the body of the constructor from the eyes of a person who's using your class. But the guts of your class cannot be initialized inside the body of the constructor. It's too late. They already are created. So the attributes can only be initialized in the default initialization or the member list. Inside the constructor, you are setting them to something. But when I say over here, item B apple, if I have something in the constructor happening, it is from main's point of view initializing B. Okay? Did I make sense, or it was absolute cuckoo? Are we okay? Okay? All right. Then we talked about moving. Did we go through moving in detail? Quickly?
No, we ended.
Okay, all right. So, what is moving? Moving is when you actually want, did I have the coffee thingy? I did that, right?
No, yeah.
We did that. So we know what is moving. We know what does it mean to move. When you have an object that is about to die, and it has, when you have an object that is about to die, and that object has resources, dynamic resources, then it just makes sense not to copy them and just take over those resources. Again, and as another example, if you want my notes, if I don't want them, it doesn't make sense for you to copy them. I simply give you my notes. That's much quicker. But if you're copying, you have to actually sit and write from mine, and then I throw it to garbage. That doesn't make sense. It's the exact same thing with the concept of moving. When you see an object is about to die, or it's an R-value object, the object that essentially doesn't have any handle, a temporary object. If that's the case, then why copy it? We can just take over its data. And that's moving. How can we detect that? We can detect that using the R-value reference. So this set thingy that we have over here, we mentioned it does the dynamic, it's kind of like allo copy that I've done in OOP345, if you remember. So it allocates and copies and sets it to null when it's listed and make sure it's deleted. So that's what the set is doing. If I'm creating a constructor, I'll call the set to set everything. Constructor is fine. I don't need to do anything. Destructor applies to both rule of 3 and 5. So as to get created, that's why we have it. Lots of people do this. if you do something like this in your code and submit it to somebody as code review, when they see that, they say, this guy has no idea what the constructor is doing. Okay? If you have a disposable cup, you don't wash it, you just throw it away. Okay? Setting that pointer to null when it's being destroyed doesn't make sense. Why you are setting it to null? You are 345 now. In 244, because we couldn't say when set the stuff to null, we said always set it null after deleting. So everybody did it blindly, which is fine. Now you know, you only delete when you are going to reuse it. You only wash your, I don't know, cup when you want to reuse it. Okay? It's the same thing. So don't do stuff like that. It's beneath you at the moment. Okay? Don't do that. You're too advanced to do stuff like that. For copy constructor, we simply set and allocate and set it, but for move constructor, which I did not write the name over here. For move constructor, what you do is essentially, you're saying, okay, the other name is about to die. First of all, the R value reference is a reference. Don't forget about that. It acts exactly like a reference. So other becomes a new name for the object that is coming in. There is no difference between a regular reference and an R value reference. They are both references. They are both aliases for what's coming in. The only difference is that you can identify that this one is actually an object that is about to go away. Because of that, you don't make the reference constant. You make it read-only. You make it read-write. So you can actually modify the one that you are taking over its stuff. So you're saying, okay, I am supposed to move your information, so I am going to point to your property. That's M first, others M first, and M last is equal to others M last. So essentially, now two objects are pointing to the same data. Now the other one doesn't need to point to it anymore, therefore I set it to null. And the other one will lose its data, and this one will gain it. No dynamic memory allocation, a simple assignment that's lightning fast. That is much faster than copying. So you will see it's going to save lots of time. The exact same happens to copy assignment. When you are doing copy assignment, you do self-checking, dynamic memory allocation, and returning this. With move assignment, you do the exact same self-checking and return this and everything, but what comes in will take over the data. The only difference is that with move assignment, you have to get rid of your own data first. So you delete your own data, then you say, now I'm going to point to your data and sever your connection with the data. Therefore, I assume your property, and I'm done. No allocation and copying is happening, and that's move assignment. So in here, I created make and stuff like that. I'm going to go to the other. I'm going to go to the next thing. So, so that was the example that we have done, and we finished it at that point. I am recording, right? Yes. Okay. So now, let's look at another move example. Something simpler that we can walk through without too much hassle. So, utility. So this is what I'm going to do. We're going to have a class called box. Let's see what does it do. Box has one integer that is dynamic. Easy. Okay? So when I create a box, I set the data of the box to a new integer with the value that is coming in. That's the constructor. Are we good? Easy breezy. Problem with this syntax? No. For copy constructor, obviously I'm copying another one, therefore I have to create my own integer. Then I have to copy the other data and put it in mine. Are we good with this? With move constructor, I am getting the other one, and I'm saying, I'm just going to point to your data, you're pointing to nothing, and done. Deleting is deleting, and showing is showing. Are we good? Yes?
About the move constructor, you are putting your new variable, the other m data, and equals to m data, the setting that you move. Doesn't that erase the data that you provide?
Yeah, it overrides my data, right? So now in here, because if it was an assignment, so if let's do the assignment too. So it's box reference operator const box reference box reference. Okay, I don't want it to be assigned to anything else, okay? But I want it to be moved. So what I will do over here, I'm going to say box reference operator. In here, I'm going to have box. Other, no exception. Now in here, I'm going to say the usual. If this is not equal to address of other, when you are writing a test, you do like this, okay? First write the skeleton so you get the mark for it, then fill in the blanks, okay? So now I'm going to say over here m. First I'm going to delete m data to wipe out mine. Then m data will be equal, so, and the rest will be exactly like this. I think that was your question, right? That you said it overwrites the other one. This one is a constructor. Because it's constructor, m data is nothing. It's not pointing to anything. I can safely point to the other data. But this one, because it's not a constructor, I already have existing data. I have to first wipe that out, then take over the other one. Does that make sense? Sure. Okay. Did I answer the question, or was it a completely wrong answer? It was good. Okay, good. All right, so now that, yes.
For other data, when we're done copying it, right, moving it over, why don't we just delete it like throw it away like you said? We're washing it.
Delete what? Delete the other one?
Yeah.
Oh my God, let me, good question, okay? Okay, so. This is one object. This is another object, okay? Now this object, didn't I click on this? Anyways, let's do it. This object is pointing to some data. You good? Now we want to move it over. So what do? So we have this over here, fine, okay? So the very first thing I'm going to do, I'm going to say, hey, I'm going to look at you. So I'm going to point to this one. Right? Now, I am saying, hey, after you have done that, make this null. Therefore, this is gone, and this is pointing to there, right? You say delete it. If I delete it, it's going to lose the data.
Oh, really?
It's the same data. If I delete this, this will be gone too.
Oh, okay.
Got it? Yeah, okay, good. Okay. So actually, I had this question, I think two, 3 semesters ago. They say, what if I copied and then deleted the other one? Like, what is the point? The whole idea is to save time, you know? Yeah, so yeah, anyways. So, did I answer the question?
Yeah.
Okay. And thanks for the question, actually. Okay, so now, let's look at the main and see what we're going to do. So I'm creating B42 over there. And I'm saying box BA. So B becomes a copy of A. But take a look at line 47. If I say box C is equal to A, what's going to happen? It's going to do another copy, right? But let's say I don't want A anymore. A served this purpose. I want to move it to something else. What do? I force it to be an L value. So now in line 47, C will take over A's data, and when we show, you'll see E has, what should we call it? A is not going to have nothing. So, and then I'm going to do this. Okay? Okay. Let's start. So this one I'm going to walk through actually. Okay, so I'm going to go F10 on Visual Studio. Take this out, put it over here. Put this one at left and this one at right. Now we can actually go through it. So we start, obviously the constructor is called, and as you see before the constructor call, it keeps going and sets it to null. That's the default initializer. And then it comes over here. Obviously the copy constructor is called. First it goes initializes it, then the allocation and copying. And now the move is going to happen. So take a look. It's too small for you to see, I think, right? You see that this says 42 over here? Okay, that's actually what we have in there. So it shows that this is 42 and this is 42 too. And then we'll go to F11. As you see, the move is happening. Now it's going to create using move constructor. It's going to first initialize. Then the data that points to nothing points to 42. The other data that is pointing to 42 is going to point to nothing now. Now we get out. If we show B, B has 42, C has 42, A's got nothing. Now I'm going to say B is set to box. It would have given me an error if I said B is equal to A, because that's deleted. Because I'm saying B is equal to box, and box is a temporary thing, what happens is that it first creates the box. So a temporary nameless box is created. Then it is going to move constructor. So now it deletes the data of the current one that is 42, points to the data of the other one that is 100, sets the other one's data that is gone. So when it comes over here, it returns this, and now the destructor of the temporary is called. But when it wants to delete the data is null, which means nothing is deleted. And it comes out. Now, B is and I show that it's 100, right? Now I'm going to say move B to C. So it is, again, assignment. It goes to assignment. They are not the same. It deletes that 42 of the C, sets this one to the data of the other one, becomes 100, wipes the other one out, and gets back. Now if I show B, B is empty because it's been moved out, and C has 100. Are we good? Moving. Now, this is moving 244 style. When I say 244 is the way I wrote the code, okay? The code should be, let me go over here, where am I? Should be written as follows. Oh, not this one. Let me go to the other one. Take a look. It does the same thing. So what I'm doing, I'm saying B and V, set the data in the member list initialization to new integer that has V. I don't need to write it in a body of the constructor. It can be done as initialization. For copy construction, I'm saying set the data to new int that has the other's data, target of the other data. And for move constructor, I can simply say set the data to other. Now I can go inside the body and set it to no. Much simpler and smaller. This is professional writing. Yes? What happens if the other data is null? Then this one will be null. This one will be null too.
Can you do new int null?
I'm saying data, other data, right? So essentially you're setting the pointer of that one to null, which means you have nothing, I'm going to have nothing.
Does it still work?
Yeah. It works. You're just copying nothing. You're just moving nothing, right? So that's that. Next thing, so let's call. So write your code like this. You're 345 now. Now, we talked about statics. So essentially, we have two types of statics that we know what they are. Number one, when you create a static variable inside a function, that makes the lifetime of the variable global, which means it will die when the program ends. It will not die when the function ends. And but the scope remains to the function. So function can only see that static. So if I call that foo 3 times, variable will be 1, 2, and 3. It's not going to die at the end. Are we good about that? The first one, static int must be file scope only, enforces a global variable to be file scope and will not have the potential to go global if somebody externs it. Remember about extern that we talked about? So if somebody says extern int must be file scope only, compiler is going to give you error. Say, hey, that's static. You cannot make it extern. It belongs to that file. Okay? That was the first static that we talked about. Now, object-oriented statics are much more difficult to grasp. So, can you see it back there? Okay. So when you make an attribute of a class static, this is what happens. So essentially, if I can find the mouse pointer, say this counter class that I have, let's say I create 3 instances out of it. So this is 1, this is 2, and this is 3. So I have 3 instances of counter created. The attribute inside the so this is essentially the counter. Now I'm going to put white over here so I'm going to put white so you know when you see white it means the object of counter. Now I'm going to create the attribute. So this is the attribute that it gets created over there. So that's 1 attribute. That's 2 attributes. So each class has the attributes of its own, right? When you are creating the static int count over here, you're essentially saying only 1 instance of count is possible. So it cannot put that static inside. It cannot put this static inside the class, so it has to put it someplace that it belongs to all and none at the same time, which means the scope of that count becomes the scope of the class. Any object will have access to it. So this object, these all have access to it, but it doesn't belong to any of them. Why? Because when they get constructed, we don't know which one is supposed to construct it, right? Because of that fact, you have to make sure that it is created right after the class definition. So right after the class definition, you should say int counter count is equal to 0. Externally create and initialize it after the class. That scope resolution, counter scope resolution, is telling that I am creating this variable for the class counter and it's being initialized. You cannot leave it uninitialized. That's where you're going to have the value. As soon as you do that, all the members of counter have access to it. For example, the constructor will add 1 to it. The destructor will reduce it by 1. So I can actually count how many instances of this object, of this class is created like that. Very simple. So, yeah. Now, I have 2 functions over here. One is print. So when you create the print, again, print is a regular function. And because it's a regular function, it exists in all, not that one, control Z. Because it's a regular function, it will exist in each class, each object. But getCount is a static method, so you can actually make a method static. By doing that, you are literally saying that, hey, you're saying I want this function not to maybe, I want it to exist on its own, okay? I want it to exist on its own, but be accessible only through the class. So because of the fact that this is a static one, just the declaration of the class will cause its creation. Therefore, you don't need to instantiate the counter to call it. Look at line 18. I can say counter scope resolution get count, and it will call the function. You don't need to instantiate it. It becomes a class method, not an object method. It belongs to the class. And be aware that these type of statics are only allowed to access the static attributes only. If I would say over here attr, print attr, which one? Because I have 3 of them. I don't know which one it can access. Because of this fact, static member functions cannot access non-static stuff of a class. But the other way is possible, is as if I'm saying, everybody point at him. We can do that, but can I tell him, hey, point at everyone? It can't. You know, you can point at one thing at the same time. Okay, so that's the thing. It's the exact same thing like this. But because of that fact, that's how it's done. Okay? So, oh, we haven't gone there yet. So you'll see later on where these things are being used. Oh, we did it in OOP345 when you were you were opening a file. When you want to open a file for read, what did you do? iOS scope resolution in, right? Something was, remember? The methods of opening a file? Do you remember? iOS out, iOS in, iOS append. You don't remember those? Files in OOP345. You did files, right?
We did, I don't remember those appending and out.
Okay, never mind. We'll talk about it now. Okay, did you do left and right? iOS left, iOS right? You did iOS scope resolution left, right? That is a static variable inside the iOS class. Because it's a basic value, they made it a static variable over there. So when you say iOS left, it's actually a specific type of bit pattern. When you say iOS right, it's a specific things like that. So it's used a lot in C++. You'll see it everywhere. Are we good? We understand what statics are, hopefully? All right. Oh, cool. Wait. I'm making a huge boo-boo. Give me a second. Control. I put it in the wrong file. So this is CD class statics. And I'm yours. Somebody had a question. Who had a question? Yes.
You said static method cannot access non-static member
Yeah.
members. But then non-static members can.
Yes. So if you look at print, print is calling get count. But get count cannot call print. Okay? And as you see over here, take a look at the code that I have over here. I'm calling counter get count, that's okay. I'm calling, I am creating the two, one is dynamic and non-dynamic. Then I'm here, again, counter get count, A.get count or B.get count. All three are the same get count because get count is static, okay? Remember the utils thing that we had? The utils class that we had that you could add stuff into, and I created a class. You had to instantiate the class and then use ut dot this, ut dot that. You shouldn't do that. You should actually create, because those are utility functions, you should create a utils class and make all those functions static. So you don't need to instantiate anymore. You simply say utils scope resolution str copy. Okay? So remember that. That's something that you need to do. So if you're having a I'll give you an example for it. Anonymous classes. Say I create a person and I want that person to have a name. What do? I create a class called person. I create a class called name. In name, I put first and last. Then in person, I'm going to write class name, name on M underline name. So I make it object oriented, right? But if you're not going to use that name anywhere else and it only belongs to a person, why create a class? It's easier to create an anonymous class instead. Take a look. I'm saying class person, struct, string first, string last, M name. So the type of M name is this. Therefore, if I want to access it, I'm going to say M name dot first, M name dot last, and so on and so forth. It doesn't have a name because I'm not going to reinstantiate it anywhere. Okay, good? Okay? Yes, sir.
So the anonymous class is that struct?
Non-anonymous class is the struct.
The anonymous class?
Is this? Yeah, I could call it a class, but then it won't be able to access it because it was private. So I can make it a class, but if I make it a class, then I hate this automatic stuff that they added to this. So when you highlight something, it just ruins everything. Anyway, so class, then I had to make it over here public. Otherwise, you won't be able to access it. Right? Okay, that's why I made it a structure. Unless you add a method to it and do stuff like that, you can. You can make it a whole class over there. It doesn't matter. You can have all the good stuff that you want in there. There is no problem with it. And the fact that when I said a class and I said a structure, you ask, that structure is a class. Structure is a class that is public by default in C++. Okay? Obviously, anonymous classes in C with typedef have been used, anonymous structures in C for a long time ago. We used to do stuff like this all the time. Okay? So, so in C language, if you recall, in IPC 144, when you created a structure, you had to rename the structure. To recreate the structure, you had to say struct something and go through it, right? So you write struct, struct person, whatever, and then to create an instance of it, you had to say struct person P. You had to do that. In C language, we created structures like this. Nobody created structures with name because it's just a waste of time. So we would say typedef struct course. So I would essentially I would say typedef this structure, nameless structure, to course. So course became a type that meant that, which means anytime I wanted to create a course, I would just say course C. I didn't have to mention struct again. So this was in C language. And I actually put the extension C over there so we know that's actually C. Whoops, I closed it. Darn. Yeah, so say you want to write a program, and when you write your program, you want to have weekdays in it. So in your program, you want to have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You want to have something like this. How would you go about it? What would you do? You could create, you can typedef integer to weekday, we could do this, right? I could type def integer to weekday, right? Then I could say constant int Sunday set to 0, Monday set to 1, Tuesday set to 2, and keep going like that, right? I could do this. So they put this thing in a package. What you see, so let me just write the whole thing. Tuesday, Sunday, Monday, Tuesday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so this is 2 and 3 and 4 and 5 and 6. Okay? So now what I have a type def weekday, and I have so I can write my program writing something like this. I'm going to say weekday W equals Sunday. I can do that, right? And then I can say if write some code, whatever it is, and then I can say if weekday is equal to Monday, if I can type it, Monday, then do something, right? Are we okay with this? They put that thing in a package. So instead of doing this, you can do this. Enum weekday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. The two are identical. It literally does that. When you create an enumeration, it creates a type of that and then starts creating constant integers starting from 0 going up to whatever. You can always give it initial values. I could do this. I could say, oh, okay, I don't want Sunday to be 0. I want Sunday to be 7, and I want 7, and I want Monday to be 1, and then the rest 2, 3, 4, 5. If you do this, then Monday is 1, Tuesday becomes 2, 3, 4, 5, 6. You can do this. So whatever you put, it's going to add 1 and keep going like that. This is how it's programmed. Okay, it always adds 1 to it. I'm going to comment this so you remember. So you remember. But if you don't put anything, it starts from 0 and keeps going up. Are we okay with this? Yes.
I missed the part where you mentioned 7. What is happening if you do 7 first?
So Sunday becomes 7.
And then it goes backwards?
If I didn't put anything, then
0.
next one becomes 8. Next one becomes 9, 10. I didn't want that. I wanted Monday to be 1 and Sunday to be 7. So what I did, I said Sunday is 7, then I'm going to make Monday 1. I'm not going to write anything. Everything after that will be added by 1 automatically. Okay? Are we okay with this, people? Are we okay? All right, that's enumeration. So the problem with that is, and this is C, it's not C++ actually. The only problem with this is that then Sunday, Monday, Tuesday, Sun, Mon, Tu, Wed, Th, FRI, and Sat will be defined values. Will be defined constant integers. You cannot reuse them. You cannot have a variable called Mon anywhere because it becomes a global thing, right? Are we okay with this? So for C++, they changed it. So this is C enum. Oh, shoot. This is last. So this is Enum. In C++, I'm going to take this out. This is what you do. That becomes C++. What's the difference? Now Sunday, Monday, Tuesday, Wednesday, Thursday, Friday become static variables of weekday. So essentially, this is what you have to do now. Got it?
Now we can.
It becomes scoped. Now you can have mon somewhere. So essentially, they call it scoped enumeration. But I call it C++, It just makes those things the scope of those, the weekday class. Are we good? You okay? Lots of syntax. EFG, scoped, C++, enum.cpp. Whew. So we covered that. Covered that. All right. Inclusion polymorphism. Inclusion polymorphism was when you have an abstract base class and you have virtuals, and the virtuals are being called when guaranteed that the latest version of the object is called. Essentially, virtuality was inclusion polymorphism. So an example for it is, forget about the clone for now, I'll explain what it is later, but look at the shape. Any shape that you have has a volume. And obviously I'm going to have a virtual destructor to make sure that it's not going to have memory leak. But so if I create a cube out of shape and it has a length, I'm just going to say cube double L. So the volume will return len plus len plus len. That's the volume of a cube, right? Now if I create a sphere of shape, the constructor works exactly the same. The difference is that I have to multiply radius 3 times by itself and multiply it by 4.18879. That's the sphere. Are we okay? Are we okay down to this point? So what is clone doing in here? Clone is something that is standard to create for abstract-based classes. By the way, this abstract-based class, what type of abstract-based class it is? Can anybody tell me? It's a special abstract-based class. Anyone? What? Yeah, it has pure virtual, but it's pure virtual. Essentially, having pure virtual makes a class abstract, I understand. But it's a special abstract-based class. An abstract-based class that has only pure virtual methods is called an interface. Okay, so this is an interface. Just remember, okay? You need to know that terminology, hopefully, if you go to CUDA programming or something. Anyway, so you see the clone thingy. Why did I create clone over there? The reason is that when you have virtuality in abstract-based classes, when you actually have series of objects in the pointer of the abstract-based class. So let's say I have an array of shape pointers, and inside this array I have series of cubes and spheres. Got it down to this point? So I have an array of shapes, and in this shape I have cubes and spheres. Now let's say the third element, I want to make a copy of it. How can I do that? If it's a shape pointer, it doesn't know what type of a shape it is. Only the virtual methods dictate what is the latest version. I cannot find out from a shape if it's a cube or a sphere. How do I make a copy out of it? It's with a function called clone. Clone is something that is customary to create by all programmers. You create a clone method. It's not like a constructor or a destructor. It's something that we do. It's a standard that we follow. When you create an abstract base class, you create a clone that returns a pointer of type of the abstract. Then you make it abstract, and you make it a pure virtual function. Now, each child must implement cloning itself, which essentially means in the clone of cube, I return a new dynamic cube copy of mine. And because cube is a shape, it can be returned as a shape. And I do the exact same thing for clone of the sphere. So sphere returns a dynamic sphere as a clone. So in main or in display volume, for example, in here, if I receive a shape and I want to create a copy of it, now I can. I can say shape S is equal to shape clone. It actually makes a clone of itself. And the copy is valid. When I print it, it's going to be a copy of that. And obviously, I deleted that at the end. So, and because the structure is virtual, everything works, I can make a copy of a class an abstract-based class without knowing what it is. And these are the examples for it. Okay, so that's essentially cloning using, when you have inclusive polymorphism, clone is a must that you need to have. Okay? No, we're good? Okay. GH. Inclusion. Polymorphism. And clones. So if you see a class has a method called clone, you should be happy. It means any type of that class that you have, you can get a copy out of it any way you want. Oh, talking about, remember about templated casts that we learned in OOP345? There were 4 of them. Static cast, constant cast, reinterpret cast, and dynamic cast. Remember that? Static casts were to cast up things that are related, okay? Like integer and a double, okay? Or if you want to cast a sphere to a shape, okay? Yeah, okay? So they are related, an integer and a double. Reinterpret cast is when you want to change the type entirely. You have an unsigned integer, you want to convert it to a pointer. 2 different things. That's reinterpret cast. Constant cast was to remove constantness. Did they give you an example of it? What constantness is? How do you remove constantness? You didn't do that? I'll talk about that later. Remind me to do it later. I want to be on track. Okay, so constant is essentially when you have an attribute inside when you have a method and the method is constant, you cannot change the attributes inside the class, correct? Let's say you have a print method. Your print method wants to print the object, right? Now you want to count and see how many times it's printed. What can you do? There's no way. So what you do, you create, let's say you create a counter inside the class and you set it to 0. Then inside your constant method, you create a pointer to an integer. And you constant cast the address of the attribute that is constant into this integer. It removes the constantness. So through that pointer inside your print, you can change the constant value. Okay? Go program it and you'll see. The other one was dynamic cast. Dynamic cast was to do an upcast, which means I have a shape, I want to cast it to a cube. That's not always successful. If I have a shape, if I have shape over there, the first one. The first one that is shape. If I cast that one to a cube, is it successful? No, it's a sphere. It's not going to be successful. If I want to cast shape 2 to a sphere, it's not going to be successful. If I cast shape 2 to a cube, it is successful. I can get a pointer and I can do whatever I want to do with it. But if it's not possible, it returns a null pointer. So remember, when you are doing a dynamic cast to do an upcast, you have to always check the pointer. If it's null, it means the object wasn't the one. It was another sibling of that. Okay? Be good? Liskov substitution principle, LSP. It says that when you are doing, this is what it says. Functions using base class references or pointers should work with derived classes without knowing it. Essentially, it means when you use a function inside your class of the base class, you don't need to care what type of a class you are. You should be able to always call it with no problem. Okay? To show you what does it mean, I'm going to show you a bad design and show you exactly what it means. Take a look at this code. In this code, I have a rectangle as a base class. Then I create a square out of it, and I'm going to say square is a rectangle whose width and height are identical. Therefore, anybody sets the, because rectangle has a set width and a set height, I'm going to say anybody sets the width to a value, I'm going to set both. Anybody sets the height to a value, I'm going to make both. It sounds like a good thing. Problem is that when we come down to here and I actually have a set for a rectangle that is a base, and I want to call the set width of it, if that rectangle is a cube, this is going to get screwed up. So I need to know the method that I'm calling belongs to a rectangle or a cube before I actually can do that, which sucks, which means it's bad design. Essentially, in inheritance, you shouldn't narrow down the base. You should widen the base to a child. Which means, if I look at this, EHI Liskov bad.cpp. So if I want to see what was the good design is this. I say I have a square with a width, and it has set width and get width. Now I have a rectangle that adds a height to a square that has a set height. Therefore, when I want to set it to whatever, I don't need to care what is what. If I say set width, it's a set width, and it's done. It works for all of them. It's not going to cause any trouble. Without knowing what is it, if I have a square, I can set a square, set height will set width will set width of anything. It doesn't matter if it's a square or it's a rectangle. We good? Okay. Quite frankly, yeah, this is something that should be taught in system analysis and design, not here. Anyways, what is the next thing? In OOP345, it's 35. Where does the class end? 410? 410? 410. I need to rest. I don't know much, because seriously, my brain is not working, and the break that I had between two classes, two students got sucked the life out of me. So I need 5 minutes break. Okay, so we're going to have a break and then we'll continue. So I'm going to end the class on time, and we're going to have a break now. Pause. Okay, so what is the next thing? So templates. We in OOP345, we talked about templates, and we understood templates are created for functions, and when we create templates, we essentially tell to the compiler how to generate something for us on demand. So essentially, when you create seriously, that music really worked. My brain is back to its normal process. So when you create a template, essentially you create placeholders and you give a signature to the compiler. Say, this is the signature that you have to match to. And if this function is never called, no code will be generated in it in your binary. You're not going to have anything in your executable called swap. But if you call the function, then you are triggering this with a compiler saying, hey, compiler, that's in a header file, compiler, I want you to call the swap with double and double. Therefore, the T over here will all change to double. You're going to have void swap double reference A, double reference B, and double C is equal to A, and so on and so forth. It generates it for you. And if you call it with two longs, it generates yet another function which overloads the other one that's going to be actually with two doubles. Are we clear on that? How does it do it? It looks at the entire function and generates it for you, as easy as that. Because of this fact, templates cannot have a two-file module. You cannot have a template which the definition of the function is inside CPP file and the declaration is in a header file. Why? Because when header file is included into your file to use the function, when you call the function, compiler only has access to the declaration. It doesn't know what the body of the function is. It cannot generate it for you. So you must make sure that you understand all templates code must exist in the header file. A module for a template is only header file. There is no CPP file. That's why you see over here we say swap.h, everything is in the header file. We good? Okay? So that's with functions.
Everything has to be in the header.
Everything. So you have to have a swap.h and write the entire thing in a header file. There is no .cpp file for it, because the compiler needs the entire thing to be able to generate the code for you at compile time. Remember, each translation unit gets compiled separately without having access to other ones. Each module gets separated, compiled separately. Therefore, if you include it, then your CPP file and the header file of the template will get compiled without having access to the body. Therefore, it's not going to get compiled. That's why they are all supposed to be in the header file. A function template. Now, when you create a template for a function, say I have a function that finds the maximum of two values. For this template to work, the greater than sign must be overloaded for A and B. Otherwise, this template's not going to work for it, right? So if I say maximum between a double and another double, then it works because the greater than sign is defined for two doubles. Or if I create a class called, I don't know, account, and account has an greater than operator overloaded for it, this will work with an account. But if I want to find maximum between two C strings, which has two values in it, to see which one comes first in dictionary, which one comes next. The one that comes next is greater than this one. I cannot use this. Why? Because if I write something like this for the main, it will not give me an error to me. It will not give you an error to me, but it's going to create a template with t being a constant character pointer. So your function will be constant character pointer maximum, constant character pointer A, constant character pointer B. And the comparison between A and B is not going to be the target of the two that are string values. It's going to compare their addresses. So essentially, it's going to return true whichever is in further address in memory. It has nothing to do with its content if it's A or B. Therefore, it's not going to work. It will compile. But when it runs, it has nothing to do with which one is coming first or last in the dictionary. Because of that fact, I have a couple of choices. Choice number one is to overload it. Overload works for everything. If I overload it, because it supersedes the template, compiler says, okay, I have an overload for maximum. I'm not going to generate any code. I'm just going to use that, which works perfectly. Absolutely no problem. Actually, some problem. What is the problem? The problem is that what is the purpose of having template? You write a template so your executable doesn't bloat. If 50 different versions of maximum is called, 50 functions for maximum will be created. If nothing is called, nothing will be created. In here, if I don't have line 22, the binary for maximum will still get created because it's the template. So how can I fix this? With function specialization. Function specialization says you can create a specialized template so the compiler calls that one when a specific type is triggering it. How do you do that? You overload the function first. After you have overloaded the function, you write over here, template, like that. Of course, you have to template like that, okay? Now, you have to add the signature to maximum. How do you do it? You put the signature here. So you are saying, if maximum is called with this type, create this function instead. That becomes the specialization. Now, that's a template too, which means if line 23 doesn't exist, that is not going to get called. As simple as that.
Function specialization?
Yes. Function template specialization. Again, you can have the overload, but it's better to specialize it. It's very simple, as you see. Now, in here, when I'm comparing a double and a double is fine. But as I showed you before, so if I say over here maximum, in here I'm going to put 20, and in here I'm going to put 123.45, or A and B. Okay? If I do something like this, which one is going to be getting created? Pardon me? Oh, D, sorry, D. My apologies. Which one is going to get created?
int goes first.
And let me just do something else. The answer is neither. Why? Because it doesn't know what to do. You have an integer and a double. In these cases, you have to tell the compiler which one to choose. So, do you want the double to be casted to an integer and the maximum come out? Or you want the integer to be casted to a double and the maximum come out? Let's say we want that. If that's the case, as specialization does it, you can explicitly ask for the double one to get created for this. Now, the compiler will call this using the double version of that one. Therefore, this int will be casted to a double and passed to it. So you can specifically request which version of the template to be called by adding the signature to the name. Overriding what the compiler wants to do. I can actually do this. I can write over here int. I can easily do that. Which means this is not going to, so it's going to be casted to an integer, and the result will be an integer. Which is a crazy thing. I'm not going to do that. But you can. You can set, you can request for a specific thing to be created, to be called in functional specialization. Are we good? Now we can do the exact same thing for classes. We can actually create classes, class templates. Three minutes left of class. Okay, so this class is behind with the other ones. I'm not gonna, I've left. Let me finish it. I'm going to come with examples the other day, on the other one, So you can do the exact same thing with classes. So you can actually create template for a class and then put placeholders for whatever you want. For example, here is an array. I'm going to say array type is T. So if I want an integer array, it becomes TA50, T dummy, and my operator is going to return an integer reference. If it's less than 50, it's going to return the A. If it's bigger than that, it's going to send the dummy value out. So it's going to be a safe array. The problem is that classes don't have signatures. Like functions, you cannot identify what class you want by looking at the name of the class. It doesn't have signature. That's why class templates must always carry the signature when you are actually creating them. So essentially you have to mention, I want a long array to get created, and it creates it for you. And that's class templates. Now, as you see, this template is only 50, right? I wish I could say I want another size. You can. What you can do is essentially create a second argument over here and say I want it to be size and I want it to be defaulted to 100. So if somebody says integer array int 10, size will be 10, I'm going to have 10 integers. If they don't mention anything, it's going to be 100. So you can pass regular values to your template. These are called non-type template parameters. Non-type template parameters. The other thing that is important about templates is to understand how we can actually create a static variable inside a template. How is it done? It is exactly like a regular one, like I have a count over here. The only difference is that when you want to create and initialize it outside, you have to mention which template it belongs to. Because each type of array that is created is going to have a counter of its own. So if I have for example, integer with size of 50, then an unsigned array then I'm going to have an array, okay? So unsigned belongs to the count, but this belongs to the array of type int with size of 50 scope resolution. So it creates that one. You have to repeat the exact same signature of the array for the constant value and add the signature for it to make sure it creates the proper count for that one. That's for statics. I'm going to come with perfect examples with these the next day. So that's that one. Class templates. And finally, to do inheritance with templates, all you need to do when you are writing the one that is going to get inherited from, you have to carry the signature for it, so it knows which one is inheriting it from. So I'm saying I'm creating a derived class that is templated, so I'm going to say when you are inheriting it, inherit from base of the same type. And that's that. Or you want to inherit it from specifically the integer type, you can say derived one is public base int. It means I want to inherit only from the base one. You can do that too. It depends on what you're going to get. And that's that. As simple as that. And that's the inheritance syntax. Inheritance syntax. And that's it. So the next day you are coming here. Template. The next day we are coming in, I'm going to actually give you proper code for arrays. There is one more thing that I'm going to say. I know I am 10 minutes off the thing. The 10 minutes it ends. I'm just going to finish it with one quick topic and then we'll be gone. Okay? Relationship between classes. I'm going to tell you exactly in a minute what does it mean. It's very simple and straightforward. The names are fancy, but what it is, it's easy. It's called composition, aggregation, and association. Okay? These three. Composition. House and a room. Rooms inside the house. A house is built up of its rooms, right? You cannot have a house without a room. There are rooms in a house that builds the house. When you're walking in the street, can you say, oh, look, a kitchen? No. A kitchen only exists inside the house. It cannot stand by itself. I cannot have a bedroom in the middle of the road. It has to be inside the house. Therefore, house is composed out of rooms. Rooms get created by building a house. Rooms get destroyed when you demolish the house. Rooms don't get created on their own. They don't get destroyed on their own. They are created by the house and deleted by the house. Done. Now bring the level of control over property lower, like a club and its members. A club has several members. A club cannot exist without members. I cannot say, this club has no members. It's stupid. It cannot happen. But if a club is closed, the members won't go away. The members are out there.
They might go to a different club.
Yeah, they go in a different club. Or I can be member of 2 clubs. It doesn't matter. Right? So, again, it's a weaker composition. It is built up of its members. It's built up of its properties. But it doesn't create or destroy them. They get created on their own. The member can exist, yeah. The member can exist outside, and you can add the members to a class. So members are created on their own, they die on their own, they have nothing to do with it. So that's that one. So this is called aggregation. Okay? Now, the other one, association, is me and you, professor and a student. I exist on my own. If I have no student, I'm still a professor. If it's summer and you're not taking any course, you're still a student. You just don't have any professors, right? But we are connected to each other. If somebody asks you, whose are your professors? You've got to say this and that and that and that. And I tell me, how many students I have? I have 200 students this semester, right? This is called association. Done, okay? I'm going to bring you the examples the next day. So please read all these things and you're done. Okay? Read all these things for week 2. Go over it, and the next day you are coming here, we're going to have samples and week 3. Okay? Are we good? Thank you. Have yourself a beautiful, beautiful day.